Here we have an extremely short page of notes. We're going to look at resistors in parallel, and whether it's resistors in parallel or capacitors in parallel or anything in parallel. In parallel means they share the same voltage. In this case, it's going to be the battery voltage. So each of these resistors that are connected in parallel share the battery voltage. And notice, depending on the resistance, R1, R2, and R3, they don't have to, resistance does not have to be equal. The currents I1 and I2 and I3 are not necessarily equal. However, they are all coming from the current that the battery was supplying, which I'm going to call I sub 0. So this I sub 0 has to equal I1 plus I2 plus I3 by conservation of charge. So again, this is a conservation of charge statement. So the flow of charge can't be greater than the charge that was available, the flowing charge initially. And if we're going to replace all three of these resistors in parallel with an equivalent resistance, we would say that the Ohm's law, right, V equals IR in general, gives us I equals V on R. And since the voltages are all going to be the same, we very nicely see that we get 1 on the equivalent resistance is 1 on R1 plus 1 on R2 plus 1 on R3 when resistors are in parallel. And again, this is the exact inverse of what we saw with capacitors, but the fact that the resistors in parallel will all share the battery voltage but split up the current is really what we need to know to do our analysis going forward. So very short page of notes. Hopefully it all makes sense, and we move along.